Okay, now we're getting into the free response questions. Here's number 9 on page 796. This is the one that involves the 3 different types, or I guess 2 different types of treatments for depression and the placebo. And so there are the 3 different types of treatment, the St. John's wort, the placebo, and Zoloft, and then there's the full response, partial response, and no response, and then they give us all the totals. So they're going to ask us questions based on this table, and this is a typical free response question involving probability. So it says, what is the probability that a randomly selected subject had no response? Now we want to make sure for questions like this that we're answering them with probability notation. Now you can write probability of n, or you can probably write probability of nr, but I think what's most common is we just go ahead and write it out. Probability of no response. Okay. Now, if we want to abbreviate, we could. We should probably put those abbreviations somewhere that the person reading it would know what our abbreviations are. Okay. So what's the probability that a randomly selected subject had no response? Well, this is pretty simple. Here's my no response row. The total number of no responses is 192 over 338. So no response, 192 over my total, 338. I could go ahead and plug that in my calculator, 192 over 338. I could probably leave it like that, but I think it might be a little bit better if I go ahead and plug this in. And I get about 0.568. And I always get asked how many decimal places should I round to. I always tell you that there's really no set standard, but I'd say it's kind of smart to just round off to 3 decimal places. For part B, what's the probability that a randomly selected subject was treated with Zoloft and had a full response? Okay, so that's the probability of Zoloft intersection full response. Don't get that confused with the conditional probability. Okay, we haven't reduced our sample space. Our sample space is still the 338 people. We're just looking now at the people that had a full response and took the Zoloft. So this is the 27 that we have here, this 27 out of our 338. And I will go ahead and reduce that as well. And it's actually 0.0798, so I'm going to call that 0.080. I know the third zero there is not necessary, the third number being a 0 is not necessary. Just showing that I rounded off. For part C, it says, what's the probability that a randomly selected subject had a full or partial response given that they were treated with St. John's wort? Okay, so this is probability full or partial response given St. John's wort. And I will write my fraction over here. Okay, so my sample space has been reduced to everybody that was given St. John's wort. So my sample space is reduced to these 113 people. So that's what becomes my denominator, 113 people. My numerator is everybody that had a full or partial response. So full or partial response. So I'm going to add these 2 numbers, 27 plus 16, which is 43. And I'm going to reduce that. 43 divided by 113. And as a decimal, I get 0.381. It's actually 0.3805, but I rounded up. Okay, for part D, what's the probability that a randomly selected subject who didn't have a full response was treated with the placebo? A randomly selected subject who didn't have a full response was treated with the placebo. So let's think about this. This is all people that didn't have a full response. So we're actually saying, what's the probability of being treated with the placebo given that we did not have a full response? So it would be a full response the complement of that, right? So let's make sure we read that properly. This is a conditional probability. What's the probability that a randomly selected subject who did not have a full response, so we know they didn't have a full response, that's given to us, was treated with the placebo. So my sample space is everyone that did not have a full response. So everyone that did not have a full response are my partial responses and these no responses. So it's actually 55 plus 192. So my sample space is out of 247 people. And my numerator are the people that were treated with the placebo. So how many of which were treated with the placebo? That's these two together, right? So those were all the people that had partial or no response that were treated with the placebo. That looks like a total of 79 individuals. So 79 out of 247 is about 0.320. Okay, so that one, again, the last question is a difficult one with the wording, was figuring out exactly what they're asking for, and then you have to narrow down your sample space and work from there. Okay, moving on to number 10. One method for increasing sales of boxes of cereal is to suggest to children that they collect a complete set of small toys. Suppose that one of five different toys is put in every box. One strategy for the company is to use or to distribute the toys evenly and put 20%, put each toy in 25% of the boxes. And what we have to do is design a simulation that will be used to assess this strategy in terms of the number of boxes of cereal a person would need to buy in order to get a complete set of toys. Okay? So it says assign digits to represent each of the 5 toys in a way that's consistent with the manufacturer placing each toy in 20% of the cereal boxes. So I think the easy way to do this is each one of these toys has to get digits that represent 20% of the total number of digits. So you could do 1 to 20 would be toy 1, and from there you can move on. But I think for me the easiest way to do this is use the actual digits 0 through 9. So if I have the digits, so the digits I'm going to use are 0 through 9. And I'm going to assign 2 digits to each toy. And that seems to be a lot easier. So toy 1 is going to get the digits 0 and 1. Toy 2 will get the digits 2 and 3. Toy 3 will get the digits 4 and 5. I actually looked at the numbers wrong, so I'm going to move these around a little bit. So toy 2 will get 2 and 3. Toy 3 will get 4 and 5. Toy 4 will get 6 and 7. And toy 5 will get 8 and 9. Describe how we'd use a random digit table to conduct a one-run of a simulation of the process of buying boxes of cereal, noting that the toy received and then continuing to buy 1 box of cereal until all 5 different toys have been selected. Okay, so I think I've already kind of started this explanation. We're going to use the digits 0 to 9. We're going to assign 2 digits to each toy. Then we would use the random digit table. So we would start working into our random digit table. So I would say start at the top left of the table. Okay? And we would work our way in and see what numbers represent a digit. We will keep collecting numbers from this table until all 5 toys are represented. Okay, now we said before that we had thrown out repeats. In this case, there is no reason to throw out a repeat. The repeat just means you've got another one of those toys. So we're not going to skip any repeats. We're just going to keep looking at these digits until we see all 5 of the toys represented. So it might take us 5 trials, it might take us 50 trials. We're just going to keep going until all of those toys have been assigned. And then it says in Part C, use the list of random digits below. So we need to go into Part C. Use the list of random digits below. Start at the beginning of the first line to carry out one run of the simulation using the process you described in Part B. You may mark the digits to help explain your procedure. How many boxes of cereal had to be purchased? Okay, so I have to remember that toy 1 was 0 and 1. Toy 2 was 2 and 3. Toy 3 was 4 and 5. Toy 4 was 6 and 7. And toy 5 was 8 and 9. And I have to keep that in my mind as I go through here. So I have to make sure I understand which toy I got. Okay? So as I go through here, I'm going to start right here. I've collected, and I'm going to mark here. Boy, marking on this table is really small, so I probably won't be able to do that. But what I'm going to do is I'm going to write out these numbers over here. So 6, 1, 7, 9, 0. So this here is toy 4. This is toy 1. This is getting a toy 4 again. So again, I've achieved toy 4. I've achieved toy 1. Now I've gotten toy 5. And then I've gotten toy 1 again. So now I've gotten 3 of my toys. Okay, so I'm going to go through the next list of random digits. 5, 5, 3, 0, 0. So with a 5, I got toy 3. With another 5, I also got toy 3. The 3, I got toy 2. So that's collected all 5 of my toys. So this is the simulation that I set up in Part 3. I'm running this simulation, and it says how many boxes of cereal had to be purchased in order for me to get all 5 toys. 1, 2, 3, 4, 5, 6, 7, 8. 8 boxes were purchased. Okay? So it says, suppose that the company instead decides to put the toys in boxes in a way that makes some of the toys harder to find. So now they've changed things up. So toy 1 will get 40%. Toys 2 and 3 will get 20%, and toys 4 and 5 will only get 10%. And now it says, how would you assign random digits that are consistent with these purchases? I'm still going to use the numbers 0 through 9. Okay? It's just toy 1 is going to get 4 of them. 0, 1, 2, and 3. Toy 2 and toy 3 will get 2 of them each because they get 20%. 4 and 5, 6 and 7. Toy 4 will get 8, and toy 5 will get 9. So this has made it a little bit more difficult to achieve all 5 of my toys. Okay? So here we go. Let's go on to the next one. Let's go on to Part E. It says use the list of random digits at the top of the next column, which is right here. Start at the beginning of the first line to carry out 5 runs. Okay? So I need trial 1, trial 2. Well, let's do this. Let's do them in order. So here's trial 1, trial 2, trial 3, trial 4, and trial 5. And I can already see I'm not going to have enough space, so I'm going to make this a little bit bigger. This is one luxury that I have with this Interwrite board is I can make things a little bit larger. Okay. So it says the probability, estimate the probability that it would take more than 10 boxes to complete the set of 5 toys. You may mark on the digits to help explain your procedure. Okay, so we have these digits kind of everywhere. I'm just going to start running through each trial, but I need to make them a little bit bigger. So I'm going to go ahead and make these a little bit bigger so that you can see what my trial looks like. And on your AP exam, you'll have a lot more room than I'm kind of giving myself here. Okay, so this should make it much easier to see how we're doing here. And again, try to remember toy 1 was the digits 0, 1, 2, and 3. Toy 2 was the digits 4 and 5. Toy 3 was 6 and 7. Toy 4 was 8, and toy 5 was 9. So let's go through trial 1. Okay, so here's trial 1. All right, trial 1, this here is toy 1. Toy 5. Toy 1, toy 1, and toy 1. Okay, so I'm 5 toys in. Now I'm toy 5. I am toy 2. So I have 3 of my toys. 7 gives me toy 3. So really all I'm looking for now is an 8, and I have to keep going until I have an 8. So all of these won't matter until I get to that 8. Now if this were my AP exam, I'd probably still say what toys they were here. So the 3 was toy 1, the 4 was toy 2, the 0 is toy 1, the 5 is toy 2, the 7 is toy 3, the 5 is toy 2, then toy 3, then the 2 is toy 1, and then finally I got toy 4. Okay? So this first trial took me 5, 10, 15, 17. So for trial 1, it took me 17 boxes. Okay, now let's try trial 2. Okay, so trial 2 is right here, and I would like to write trial there, but I don't have room. I think if I were going to do this, I would write trial 2. So this here is toy 1, a 5 is toy 2, 3 is toy 1, toy 2, 1, 2, 2, and 2, 4, 1, 4, 2, 1, 3. Wow, and we're going to go for a while until we see a 9. So we're actually going to have to wrap into the next row. Or we could have went up into that upper column of upper area of random digits. I don't really know what those are doing up there, so we're just gonna pretend that we don't see those. But we're going to have to keep going until right here. This is where I'll finally see toy 5. Okay, so toy 3. This is toy 1, 3, 3, 3. Let me mark these very quickly. Okay, and then finally down here I saw toy 5. So it took me 5, 10, 15, 20, 25, 26 boxes of cereal. Okay, and so I'm going to go ahead and start. We're going to start trial 3 here. So this is where trial 3 will start. And now I'm getting kind of messy, but if this was your AP exam, you'd have a lot more room than I'm currently showing you right now. Okay? So trial 3 will start. We have toy 5. We have toy 2. A couple of toy 1s. All right. Then we have another 1. We have a couple of 3s. A couple of 2s. So really all we need is a toy 4, which I think is all the way down here. But we have to mark these still. Toy 2, toy 1, toy 3, toy 2, and toy 4. And I'm just marking them just to show what's going on. So here it looks like we had 14 in our box, 14 boxes in trial 3. And this free response question is taking a lot of time. My guess is that a question like this with this many parts would probably be an investigative discovery, which would be a number 6, a problem number 6. Okay. Now I'm going to jump. I'm going to jump down here for trial number 4. Okay. And I'm going to start it right here. Let me move this just a little bit so I have a little bit more space. That's where trial 3 started. So trial 4 will start right here. Trial 2, trial 1. Actually, yeah, that works. We'll start trial 4 there. I could have probably started trial 3 on this line, but I didn't. That probably wouldn't have been a terrible idea, but I don't think it matters either way. I could continue going here with trial 4 if I wanted. That's fine too. It's random digits, so it doesn't really matter where you start each trial. So trial 4, we're going to start here. We got toy 2, toy 2, toy 2, toy 3, toy 3, toy 3, toy 1, toy 3, toy 1, toy 5. And then we've got a couple of 4s, a couple of 2s, and then another 4. I actually went too far. I had 2s, 3s, 3, 1. So actually I just needed this 4. That gives me 1, 2, 3, 4, 5. Yes, I think I got a little too far with that one. So that one actually only took 11 boxes. So trial 4 was 11 boxes. And we're almost done. Trial 5 is next. And trial 5 I'm going to put right below it. Here's trial 5. So toy 1, toy 5, toy 2, toy 4. So all we need is a 3, toy 2, toy 4, and these are all 1s. Hey, and a 3. That one's the shortest one. That one was 10 boxes. Ooh, that was exhausting, okay? But that's what it asks us to do. It asks us to run a simulation, kind of mark on the digits, but run the simulation 5 times, and that's what we did. And we noted the number of boxes we purchased. It says the probability estimate from part E may not be a very good estimate of the actual probability of boxes. Okay, so we had to give a probability estimate. I guess that's something I can't read with that being over there. It says use your results to estimate the probability it would take more than 10 boxes to complete 5 toys. The probability that we have more than 10 boxes here, well, I had 4 that took more than 10 boxes out of 5, so it's 4/5. Okay? So that's the probability it took more than 10 boxes to get all 5 toys. All right, so let's go ahead and look at the last part of this, which I believe I'm covering up right now. So how can I get to that? All right, so it says the probability estimate in part E may not be a very good estimate of the actual probability that more than 10 boxes must be purchased. What would you recommend doing to increase the accuracy of this estimated probability? Well, if I want to increase this accuracy, I have to do this a lot. So doing it 5 times isn't very much. So to increase the accuracy, what I would want to do is I would want to increase the accuracy. And there's this silly thing that College Board likes seeing, which is kind of restating their words. So to increase the accuracy, because they said it in that sentence, I should say it. So to increase the accuracy of the estimated probability, and this also puts it in context. Which I never really liked, but if we know that they're asking for it, we might as well do it. So to increase the accuracy of the estimated probability, we should do as many trials as we possibly can. So we should run as many simulations as possible. The more, the better. The more we run, the more accurate our estimation will be. Now the good thing is we wouldn't have to use a random digit table. We could probably use some form of statistical software to do this a lot quicker and do thousands of trials very fast. But that's the easiest way to simulate this this probability, is to just keep running more and more trials, and you'll get very, very accurate results if you run enough trials. Hope this helped. Good luck.